Hey, math analysis. All right, so I'm really sorry that I can't be with you today, and I hope you all had a wonderful winter break and a happy new year and all that stuff, and hope your day is going a little bit better than mine. I'm stuck home with a sick 3-year-old who has caught the stomach bug. Ugh. So I'm literally like disinfecting my entire house. Okay. Anyways, we still need to move on with math, and it's our first day back together. So I'm making videos for you so that we can catch up on some notes. 1, it's a stupid amount of worksheets. I'm really sorry. I should have photocopied them front and back. I don't know what I was thinking, but yesterday was the first day back from winter break, and I wasn't quite ready to go to work yet, and so I'm sorry. Here we go. When we last met, we finished up our test on polynomials. In that unit, the only thing we didn't cover was polynomial applications. So what we have here is a bunch of word problems that we're going to work through, and they'll be done with polynomial applications. So you might be thinking, wait, we tested on polynomials. So how's this going to work? Well, what's going to happen is we're going to do some practice problems for our notes today. We'll do a few practice problems next class, and then we'll have a quiz. Okay? So, don't you worry. It'll be a short, 3-question word problem, just like the ones we're going to do here as we begin to talk through them. So, first one we're going to do is the metal worker problem. So, make sure you have this worksheet out. We're going to go through this one together. Then there'll be some times where I tell you to do the other worksheets to try them. Pause the video, come back, and then we'll go and work through them together. Alright, so we're talking about the metal worker who wants to make an open box from a rectangular sheet of metal measuring 12 by 16. Doesn't say inches, feet, whatever you want to make it, works for me. The idea is we're going to cut out these little square corners and then fold up the sides. Hopefully, you've seen this where if you were to cut a square out of the piece of paper and then fold it up, you make a box. I'm really sorry I can't be there to show you how to do this, but hopefully you can visualize it. If not, try it. Take a piece of paper, not this worksheet, okay, cut out some square-ish type of corners, and then fold up the remaining sides, and you'll see that you have an open top box. So, think about it here. I want to write an expression that represents the length, width, and height of this open top box. Okay, the whole length in general was 16, but then I cut out 2 squares from it, and those squares had a dimension x by x. So now our length and the new length of the actual box, once we fold it up, is the original 16, taking away the 2 length of the x's that we took out. Then we have the width, following that same idea. The width was originally 12, but we cut out 2 of those boxes from the corners, which had a width of x, so it became 12 minus 2x. Now, when we fold it up, that height is actually what we cut out, and that height is just x. So then, we go to part B, and it says, using your answer from part A, write the function for the volume. Alright, volume of a rectangular prism is length times width times height. That is a formula you're going to need to know. In this case, using everything in terms of x, our length was 16 minus 2x, our width was 12 minus 2x, and our height was x. Okay? So again, that's length times width times height, and that's taken from the drawing and the subtracting and cutting out of the square corners, which have the dimensions x by x. If you have any questions on this, write them down, and we can talk about them when I see you guys next. Jumping on to part C, it says graph your function. So you're going to get out your handy dandy calculator, share with your neighbor if you don't have one, okay? And you're going to graph this. Remember, it was 12 minus 2x. Make sure you put it in parentheses. 16 minus 2x times x, and graph it. Okay, you're going to need to adjust your window. Okay, someone in my period 2 class yesterday goes, can't you just hit zoom fit? That doesn't always show you the max and mins. I recommend just playing with your window. Even if you go over what you need, you want to be able to see the full graph. And you can tell based on that volume equation. Again, that volume equation, I'm just going to put the x in front. 16 minus 2x and 12 minus 2x. That was the volume equation. You can see x times negative 2x times negative 2x. It's a degree 3. The leading coefficient is going to be positive, so you should be able to get the end behavior going on. I have a graph that looks something like this. Okay? So, here's what I'm going to say what you need to do next. Graph the function, check. Find the max volume that can be contained in the box and the size of the square cut that produced this volume. Alright, we need to find the max. Here's the maximum. This graph represents the graph of the volume. It doesn't make sense to look at any of the negative volume. You can't have it. So, graph your function, find the max. Second, trace. 4. Go to the left, arrow to the right, hit enter, and I got that our x value was 2.26. Okay, again, this is a word problem. There should be units. Okay, we can just go with inches. You could say feet. It's not assigned to you right now, but you want to make sure that you always include word problems. The volume I got was 194.07, and in terms of units, that would be inches cubed. So, make sure you did everything the problem's asked. Find the maximum value that can be contained. That's here, 194.07 inches cubed, and the size of the square that produces this volume. Check, done. Other questions might ask you to state the dimensions. If that's the case, you would just plug x back into the length, the width, the height, and get all 3 of those dimensions. If you have any questions, work together. Maybe some of you can answer them for each other or jot them down, and I can answer them when I see you again. So we're going to take this example, and now we're going to move on to try another problem. Let's go through this one together. All right. Several popular models of carry-on luggage. I would much rather be off to be going on a trip somewhere and not staying home with a sick toddler. Think of where we're going, guys. Let me know. Let's take a trip. Where are we going? Maybe some of you just went on a trip. It was winter break. I didn't go anywhere. Hopefully you guys did. Tell me about it when I see you on Thursday. Remind me, because you know I'm going to come in and start doing all math, and I want to hear about your winter break. So please, remind me. Alright, here we go. First of all, part A. Assume that the sum of the length, width, and depth is 40. Write that down. L plus W plus D equals 40. Hey, they give us units, inches. Right, and graph a function related to the volume. Volume, in this case, is length times width times depth. Okay, they use L, W, and D instead of height. No big deal. Same formula. All right, but here's the thing. We need to determine all of these in terms of x. So, we're going to say that the depth is x. We'll call that x. And then it says all this luggage has a length 10 inches greater than the depth. How do I represent that? You should be shouting out x plus 10. All right. Now we need to find our width. And you might be thinking, Ms. Gutierrez, that doesn't tell us anything about the width. And you're right. But guess what? We know L plus W plus D equals 40. So therefore W would be 40 minus L minus D. All right, now let's come back over here to the volume. Volume equals our length, x plus 10, our width, 40 minus x plus 10 minus x, and then x. Sorry, I'm writing over top of the yellow, but that's how we have different colors. And I just write ginormous. Distributing that negative, combining like terms, gives me x plus 10, 30 minus 2x, and x. Leave it in this factored form. Graph it. Go to your calculator. Again, 30 minus 2x, x plus 10, and x. We got all of it down. Graph it. You're gonna have to adjust your window. So, let's see what we got going on here. My graph looks a little something like this. That should have crossed through there, but that's okay. Go ahead and find the zeros here. Okay? Because we're asking about the realistic domain. And don't tell me all real numbers because it makes a cubic function. It's luggage, people. It can't be negative. That would be a degenerate like luggage. You couldn't hold anything in it, and we all want to be able to take our stuff with us when we go on our fabulous vacation. So, I got negative 10, 0, and 15. Remember, what does this graph represent? This graph represents the volume. So we can have negative volume, and we can't have negative x values because x represented the depth. So that means we have to be between 0 and 15. We can't equal them, though, because then we would have a volume of 0, and it means we're taking nothing because we don't have a suitcase. All right, questions there? Write them down. Ask each other. Maybe you can work through it. Here we go. What is the maximum possible volume? You need to adjust your window. I'm doing negative 1,500 for my Y min and 3,500 for my Y max to make sure I can get the full volume. All right, must find the maximum. Second, trace. 4, left, right. And the good thing is, guys, there really should only be one max. So you're only finding one max. And I got that it was 8.9 units, inches, giving us the volume of 2,052.2 inches cubed. And there we go. Oh, wait, read the question. Maximum volume possible. Got it. What are the corresponding dimensions? Well, the depth is 8.9. The length is x plus 10, or 18.9. And then you do 30 minus 2 times 8.9, and you're going to get 12.2 for the width. Again, all of those are inches. Keep in mind, my decimals are kind of looking like commas as I write on this iPad, so just bear with me. Okay, part D. Part D says, suppose the airline allows us to bring on bigger luggage, and the sum can be now up to 45 inches. Find the possible volume and the corresponding dimensions. So that changes our equation. We still have x plus 10, but now instead of 40, it's 45 minus x plus 10. So when you distribute this guy and combine like terms, you get 35 minus 2x. Changing this graph If you use the window I said above up to that 3,500, this should still fit that. Okay? So, changing this. Here we go. Second trace maximum. And goes left. Go to the right. I really wish there was a way to get my calculator screen on the iPad screen so you could see it all. But hopefully you're able to find the max easily. Okay, so I got that the x would equal 10.5 inches, giving me a volume of 3,013.6 inches cubed. Okay, and again, dealing with the dimensions, plugging in 10.5 into the values above, I would get dimensions 10.5 by 20.5 by 14, all of that of course. Alright guys, apparently I've been sitting here talking to myself and I have no idea when this video stopped recording. All of a sudden I looked up at the top of the screen and it said resume recording, and I was like, oh crap. So quickly I'm going to talk through C and D again just because I don't know when it stopped. And if this is a repeat because it didn't stop too far or however long ago, then just fast forward. Okay, so part C, graph the function, find the max, 8.9 with the volume 8.9 inches for x, that was the depth, volume of 2,052.2 inches cubed, gives you 8.9 inches for the depth, adding 10 for the length will give you 18.9, and then doing 30 minus 2x gives you 12.2. Okay, there's the dimensions. Part D, changing it to 45. Okay, so when we change it to 45, the only thing that changes is this number right there, okay, which will then change this from 30 to 35, and then that would give us, same thing, finding the max, getting 10.5, a new volume of 3,013.6 inches cubed, and plugging that 10.5 into x plus 10, and 35 minus 2x give you the dimensions of 10.5 by 20.5 by 14, all in inches again. Okay, sorry about that. No idea where it stopped before. Oh, technology. Here we go. Moving on. Now we've done 2 worksheets together. Kind of, you call this like video together. I want you to take this worksheet, worksheet number 3, and try it. Pause the video, stop it, come back to this part, whatever, but try it, and then we will continue, and you can go over it together. Here's what I'm going to say, though. Don't do part 3, okay? I don't really need to know the window you chose, because the window that works for you might be different than what works for someone else, and that's okay as long as you can see the graph. Alright, try this one, come back, we'll talk about it, then we'll move on to worksheet number 4. You're going to try it, we'll go over it, and we're done. And you have 3 problems out of the textbook for homework. Sweet. Alright, pause it, do the worksheets. See you in a bit. Okay, so let's go ahead and work through this one. Hopefully you did it. And here we go. Drawing a picture. Boom. We have our rectangular 12 by 20 inch piece of cardboard, and we're cutting out equal size sections, x by x. Okay, so we're going to write the equation that represents the volume of the box. This is very similar to the metal worker problem we did on worksheet 1. Volume would be 12 minus 2x by 20 minus 2x by x. Leave it in factored form. You will not have to distribute this. Alright, moving on. What would be a realistic domain? So you graph this guy, and you go to y equals, and you say 20 minus 2x, 12 minus 2x, and x. And you're going to get a graph that looks something like this. And when you find these values, you're going to go ahead and you're going to get 0, you're going to get 6, and you're going to get 10 as your zeros. And you might think the domain should be 0 to 10, but remember, this represents the graph of the volume, and you can have negative volume. So really, the realistic domain would only be from 0 to 6, okay? That's where we achieve our maximum and everything like that. Okay, so then it says, find the value of x that maximizes the volume. Second trace, 4, left, right, enter, getting that x value. I got 2.4, and I believe we are dealing with inches here. Yep, inches. And what is that volume? 262.7 inches. Okay, all that's good. All that should have been hopefully relatively easy because it's very similar to the first example we did together. What's different is part 6. In number 6, they want to say for what values of x, solving for x, is the volume equal to 200? Well, remember our volume was x times 12 minus 2x times 20 minus 2x, and now we're saying that equal to 200. And there's a few different ways you can solve this. The first way I would solve it is you already got this guy, that left-hand side, in y1. So I'll go ahead and put 200 in y2, graph them, and find the intersection. How do you find the intersection? Second trace, 5. Enter, enter, enter. You're going to have to do it twice, though, because there's 2 intersections. Makes sense if the maximum was 262.7 that you would have 2 x values giving you a volume below that. So I got x equals 1.17 inches, or, well, that's a really horrible R. Let's try again. Guys, it stopped recording on me again. I swear every time my iPad goes down 1%, it just stops. I'm at 5% right now. I'm trying to get through this as fast as possible, but I genuinely have no idea when I stop talking. And I'm so sorry to do this to you. This is probably the worst video I've ever made, but I honestly don't have time to go back and make a new one unless you want a screaming toddler in the background. So, let me, hold on, go back here. Hopefully, we finished talking about this one and I made it through this problem. If not, here we go. Speed round. Domain was 0 to 6 because that is when the graph is above the x, and we can't have it be below the x-axis. Okay, so that's why it's 0 to 6. Finding the maximum value. Second trace 4, find the max, boom, 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 type it in, 2.4 inches for the x, 262.7 inches. Ooh, that should be cubed. Let me fix that. All right, there we go. Going back and fixing it. Part 6, setting the volume equal to 200. 2 different ways you can solve it. In my opinion, the fastest way is to put it in y1, the left-hand side, y2, the right-hand side, and find the intersection. 2 values, 1.17 inches or 3.9 inches. Okay, back over here. Cheese. Okay, this picture is part of the problem. Okay, so you have a 2-inch slice of cheese that is cut out from one face of the cheese block as shown. This picture is supposed to be on your paper. Go ahead and try to draw it in. Okay? It tells you the remaining solid has a volume of 224 inches cubed. Find the dimensions of the original block. The original block is x by 4x. Okay? But you have to find that volume. So what they tell you is the volume remaining. The volume remaining, okay? And let's get a pen. Here we go. The volume remaining. All right. x by x. That's the face of the cheese. That's this part by this part. By. It's not 4x. 4x is the original. We subtracted a 2-inch slice. So that volume equals 224. Going ahead and distributing that, I have 4x cubed minus 2x squared. Much like example 6, the easiest way to find this answer is to graph it on your calculator. Type in 4x cubed minus 2x squared in y1. Type in 224 in y2. You're going to need to adjust your window to see what we have going on here. Okay. So I got an intersection of x equals 4. X equals 4. Again, I graphed the function in y1, 224 in y2, second trace 5. I got that x equals 4. In this case, it would be inches. The questions say, find the dimensions of the original block. All right. So, the original block was x times 4x, or 4 by 4 by 16 inches. And yes, that's a big brick of cheese, but it's still probably as delicious as a small brick of cheese. So, questions here, write them down, we'll go over them. All right, let's see if we can get through this without the iPad stopping me or dying, because we have one last problem. Oh, no, don't like that picture. Let's zoom in. Here we go. The water level in a fishy tank. Okay, so we're talking about a fish tank. Take a second, try this problem, pause the video, then come back and we'll go over it together. Okay, so let's go over this one. The water level in a fish tank is 4 inches from the top, people, from the top, not 4 inches. That would be a little bit of water for a few fish. The depth of the water is the same as the width of the tank. The depth equals the width. I'm going to call that x. Okay? The height, or sorry, they use the word length. Depth, width, length. Trying to make sure we use all the same terminology in the problem. Okay? The length, okay? The depth of the water is the same as the width of the tank, which is half the length. So if this is x, and that's half of the length, we're going to call the length 2x. That makes my volume x by 2x. And that volume of the water being 4,394 equaling 2x to the third. Okay, going ahead, graphing this one. And we're going to get that x equals 13 inches. So then, that's just the water. Okay? It says, what is the capacity of the fish tank? Okay, well, I have x. But for the actual tank itself, let's erase that and get a different color in case I run out of room. We'll go back to red. Okay, so for the tank itself, it's going to have the depth of the water doesn't quite equal the width because it's actually 4 inches from the top. So it's going to be x plus 4 by x by 2x is the actual capacity of the tank if the water was taken through the very, very brim and not going over. So that means the volume capacity of the tank would be 13 plus 4, aka 17, times 13 times 26, which is 2 times 13, and that would give you a volume of 5,746 inches cubed. Okay, so here's what's happening. You have 3 problems out of the textbook. Okay, numbers 65, 66, and 71. I forget the page number. The substitute can tell you and write them on the board, hopefully. There's textbooks on the side, okay, in that little cubby thing on the wall by the front door. And you can work on those 3. When I see you on Thursday, we're going to go over any questions that you have. We're going to go over your homework problems. And we're going to do 3 more examples, basically like a practice quiz. My hope is that after we do that practice quiz, then we could just knock out the real quiz and be done. If that doesn't work, we can just move on and introduce the next unit, and we can take the quiz on the following Monday. That's totally fine. Okay? I just know you guys don't like it when we start new stuff before a quiz and you'd rather just review. The problems that are going to be on your quiz are going to be just like these here. Everything relating with the calculator, okay? Rectangular prisms, whether it's cutting out the corners and making a box, talking about luggage, fish tank, cheese, okay? All sorts of stuff. But we'll talk more about it when I see you on Thursday. I know this was not the ideal scenario, and I'm very sorry for that. Just know you can also pop in tomorrow and see me, and we can talk about more stuff then. Certainly sign up for Viking Time, and we can go over any of this together with that also. Have a great day, guys. I'll see you Thursday.